So we are now moving on to area in our series, and we've covered perimeter already. The first thing we want to ask is, what is perimeter? Now you guys should know the answer to this. So I saw hands go up. Let's take the first hand. Shady, yes.
Ma'am, perimeter is the distance around a shape.
It's the distance around a shape. So perimeter, it is our total distance. So total distance. And what is a specific about the shape? How many dimensions should it be?
4, I think.
No. So you're thinking sides. We're not talking about sides. Must it be a 2D shape or a 3D object?
A 2D shape.
So it must be a 2D shape. When we're dealing with perimeter, it's always 2D shapes. So my perimeter is the total distance around a 2D shape. Now, Shady, while you're here, can you tell me what is the formula, like a general formula for the perimeter?
Well, isn't it like length times breadth for a square? Or just all the sides added together?
It's all the sides added together. So it's side 1 plus side 2 plus side 3. So you're just going to add up all your sides. So in other words, it is the sum of all sides. Make sense?
Yes, ma'am.
Oh, jeez. I feel like I don't know how to write anymore.
Ma'am, and Demi can't hear you.
I saw that. Thank you, Shady. Let me try and type. I don't even have my keyboard. Try this. Demi, could you possibly hear me now? I'm taking that as a no. No. Okay. Somebody please do me a favor and type for me and tell Demi to try leaving and rejoining. I will wait for her for 2 minutes, 1 minute, 1 minute. Okay, let me actually just. Thank you, guys. Can you hear anyone else? Can Sliako, maybe I know you like to talk. Can you try talking so that Demi can tell us if she hears you? Is Liako gone? Okay, it's in delay. Do you want to try?
Ma'am?
Yeah, okay. There we go. Okay, she's back. Demi, can you hear us now?
Ma'am, you said me and Liacho like talking. Ma'am, there's Umar in all of this.
You're actually right, but Umar doesn't tell stories as much as you guys do. Umar just answers questions, and then he's sort of done. You guys are storytellers.
Yes, ma'am, I know.
Demi? Classy apples. I like that. Let me type. There we go. Okay, good to have you back, Demi. Let's carry on. Thank you, Tandile, for helping.
It's my pleasure, ma'am.
So perimeter is the sum of all of our sides. Now we're moving on to area. So let's look at area. Can anybody maybe tell me what is area? May I answer the next one? No, that's not Itandile. Imihle, do you want to tell me what area is?
Hello, ma'am.
Hi.
Ma'am, so area is the the space in the inside of the shape.
Right. It's the total space on the inside of a 2D shape. Thank you. So you can say it's the total space on the inside, or you can just say it's the space that a 2D shape takes up. And so here there's sort of a different formula for each shape. But what you guys should know is if my perimeter is the fence around my farm, my area is going to be what I would need to know if I wanted to put grass on the farm. So if we have our little farm over here, if I wanted to put a fence around it, I would need to know the perimeter. But if I wanted to put grass on the farm, I would need to know area. Are we all happy with that and are we understanding?
Yes, ma'am.
Cool. Thank you for answering, Emise. Okay, Liako, I did see your hand was raised, literally. Sorry.
That's fine, ma'am. It's fine.
Okay, moving on. Let us look at some of the basic formulas we need to know. When we're looking at a square, okay, remember properties of a square are super important. Remember in a square, all the sides are the same length. So if one side is length x, we can say that the area is x squared. How did we get x squared? Because we said the area is equals to x times x, and that gave us x squared. Now, I know a lot of us don't use the x squared, but instead we say side. So area is equals to the side squared. Same thing, just a different variable. So that is my formula for the area of a square. If we're looking at a rectangle, it's pretty similar. The only difference is that if we think about the properties of a rectangle, we have two pairs of opposite sides that are equal. And so here you'll see this picture has breadth and height, but I know normally what we use is length and breadth. So this would be length. Now, I know a lot of you guys get caught up on which side is the length and which side is the breadth. What I want you to know is it doesn't matter because the formula is the area is equals to the length times the breadth. It doesn't matter because let's just say you say that the length is 6 and the breadth is 5. Even if you swap it around, you're still going to get 5 times 6. Even if you say that the length is the breadth and the breadth is the length, your numbers are just going to be swapped around. But because it's multiplication, it doesn't matter. So I don't want you guys to get too caught up in, ma'am, which one is the length and which one is the breadth. Usually I know we say that the longest side is the length and the shortest side is the breadth. So if that makes you comfortable, then stick with that. But it's not important for you to know which side is the length and which side is the breadth. What you should know is that it's the long side multiplied by the short side. That's all we need. It doesn't matter the order that you multiply it in, as long as you have the correct numbers, you'll still get to the correct answer. So that's a square and that's a rectangle. Are we all happy with those two? Cool. And then we have a circle. Now, we introduced circles to you guys last week. Now, when we're dealing with a circle, we do have an area of a circle. And remember, when we speak about a circle, we have the center of the circle. And a line from the center to the edge of my circle is called the radius. So the formula for my circle to get the area, my area is equals to pi r squared. Now, with these two formulas, if you remember the formula for perimeter, it's 2 pi r. So what I always like to do to remember these formulas is I think, okay, when I calculate perimeter, I just have normal units, okay? So it's 2 pi r. But when I'm calculating area, my area is always going to be in squared units. So what we do is we take the 2 from here and we make it an exponent. And that's how we get pi r squared. That's not a mathematical thing, just to be very clear. It's just something I tell myself to remember which one is the formula for area and which one is the formula for perimeter, because it's so easy to confuse the two. But remember, when we're doing area, we have squared units. So the one with the square is the one for area. And when we have perimeter, there is no square. So the one with just a normal 2 is my perimeter formula. Are we all understanding the circle formula for area? Cool. What I want you guys to see, what's super important, is that the formula is not pi times r squared. My square is only attached to my radius. So what you have to do when you're doing calculations for this is you will literally say pi multiplied by r multiplied by r. So that's how it works. You're not going to square pi as well because there are no brackets. If there were brackets, if it was a bracket like this, and so let me maybe erase all of this. If we had brackets where it was a is equals to pi r and then squared, then you would distribute your exponent and it become pi squared r squared. But that is not what my formula is. My square is only attached to my radius. So you guys need to be super, super careful with that. Don't make that mistake because I see it a lot. Our next one, Itandile, do you have a
Thank you, ma'am.
pleasure? You can see it now, Itandile.
Yes, ma'am, I can. Thank you.
Then we have a triangle. So what you guys should know about a triangle now is in a triangle, we have what we call the base. So that's what this B stands for. The B is the base. And then we have the height. So my H is for height. So when we are calculating the area of a triangle, we say half multiplied the length of my base multiplied by the length of my height. Now, what you guys need to know is it is not a slanted height. So you cannot go and take this line over here and say that this is the height. Super important is that this is not just any height, but it is your perpendicular height. What does perpendicular height mean? It means if you have your base, we want to know if we were to draw a perpendicular line on our base, how long would this perpendicular line be to get to the top of the triangle? So for example, in this triangle, this line over here is what would be my perpendicular height. Now I know you might say, but ma'am, this and this look like it's the same length. I mean, they do look like they're the same length, but remember in maths, we can never assume. We can never assume. Let's take a triangle like this, for example. Okay. If I have a triangle like this, how would we find our height? Well, if we're going to call this my base, what we do is you have to draw a line from your base to the top corner. So right now, this is my top corner. So what I do is I go and I extend my base and I draw this perpendicular line over here. Do you guys see how this dotted line is now the height of my triangle? It is the perpendicular height of my triangle. Good, I'm glad. I cannot say that this purple line, I cannot say that this is the height. That's wrong. This is a slanted height. We're not worried about slanted height. We want to know what is the perpendicular height. Cool. So let us move on and let us look at some examples. I think I'm going to do these first ones. So let's look at this. Determine the areas of the following shapes. Can anybody recall what the formulas were? Now, first, before we even do that, what shape is this, you guys? Let me take a hand. Let me see. Immediately, your hand has been up. So, what shape do you think this is?
It's a square, ma'am,
Why do you say it's a square?
because all the sides are equal, ma'am.
Right. We can never assume it's a square. But because they've told me all my sides are equal and all of my corner angles are 90 degrees, those are the properties of a square. So because those are my properties of a square, I can use the formula for area of a square. What is that, Imithle?
It's S square, ma'am.
The area is equal to your side squared. And what would that be?
It was equal to 4 squared, which equals 16 centimeters, ma'am.
16 centimeters. But remember, it's always centimeters squared. If you think about what's happening here, 4 squared, it's actually 4 centimeters times 4 centimeters. What's happening here is your 4 is being squared and your centimeters are being multiplied to each other, meaning your centimeters are also going to become squared. Do you see that?
Yes, ma'am.
Cool. So that is that. Thank you for that one, Inise. We have the next one. And I said I was going to do it myself, but even when I do it myself, I always take you guys up to answer. So, Shady, what do you think B is? What shape do you think B is?
B is a rectangle.
Why do you say that? What are the properties that you recognize of a rectangle?
Opposite angles are equal to each other.
So, not
And
angles, but opposite sides.
opposite sides, yes. Opposite
Mhm.
sides are equal to each other.
And
I don't know what else.
the 90-degree angles. Remember, there's a lot of quads where opposite sides are equal to each other. Remember, in a parallelogram, we also have opposite sides equal to each other. But it's specifically the 90-degree angles that make the difference between a parallelogram and a rectangle. Do you see that?
Yes, ma'am.
Cool. So now, because we see these properties, we know it's a rectangle. What is the formula?
Length times breadth.
Length times breadth. Beautiful. And then what are you going to substitute for what?
Breadth would be 4,5 meters.
Okay. Mm-hmm.
And length is 2 meters.
And length is 2. And what's my answer?
9
9 what?
meters.
Meters what?
Square.
Squared. Remember, it's meters times meters, which is meters squared. Super important to include your squared units.
Yes,
Hey,
ma'am.
that is that. Thank you, Shady.
Thank you, ma'am.
Now, what I want you guys to see is if you said, well, length is my long side and breadth is my short side. Oh, I thought I changed the color of this. And breadth is my short side. You still would have been correct in that you still would have had 4,5 times 2, which still would have given you 9 meters squared. So these are my super basic shapes. Use your reactions. Let me know how we're feeling about this. Cool. Great. Love to see it. Let's move on. And let me go up. There we go. Itandile, do you want to try and help me with this next one?
Yes, ma'am.
Okay, cool. So firstly, what shape is this?
Ma'am, it's a triangle.
It is a triangle. What is the formula for the area of a triangle? Do you remember?
Its area is equals to half times breadth times height.
So not breadth. Be super careful. It's not breadth, but rather base.
Yes, ma'am, base.
And we always want to just be super sure. When we're starting out, I'm always going to write perpendicular height just so that I never forget. Cool. Now, what are we doing, Ethan?
Ma'am, we say half
Mm-hmm.
times 8
Mm-hmm.
times 7. So half is equals.
So we can simplify this one bit at a time. What is half times 8?
It's 4, ma'am.
It's 4. So that's 4 times 7. What's 4 times 7?
4 times 7 is 28
20.
centimeters square.
Thank you. And that was that. Super, super easy. Obviously, we'll get into more complicated ones, but this is the super basics. Thank you for helping me, Ethan.
It's my pleasure, ma'am.
Cool. And before our brain break, we have a circle. Now, our 3 lovely ladies have already answered. Does anyone from the boys want to represent and answer for us? Nobody. Girls are on fire. I agree. Kia, do you want to answer? Kia, can you answer for me? Yo, guys. Just now, I'm going to start name calling.
Ma'am, can I answer?
Sure, Demi. I think that's Demi. Demi, am I
Yes, ma'am.
correct? Cool. Demi, let's go. What are you seeing? Firstly, what shape is it?
A circle.
What's the formula?
2 times pi times 5.
Okay, give me the formula without any values in it. What's the general formula for the area of a circle?
2 times pi squared. No. Oh, sorry. Pi times radius squared.
Correct. Pi r squared. So remember, when we have area, there's no normal numbers because we have squared units only. When we're dealing with perimeter, then we'll have normal numbers because we have normal units. Make sense?
Yes, ma'am.
That's just a easy way to remember it. So it's pi r squared. Now that we have the formula, what are we doing?
Pi
Mm-hmm.
times 5
Mm-hmm.
squared.
Beautiful.
And that is pi times 5. Pi times 25.
Mm-hmm. What is pi times 25? Simplify this as best as you can without using a calculator.
78.
So you are now using your calculator. Remember, Demi, when we have this, it's always easier to just say pi times 25 is 25 pi. And then all you have to do is type in 25 pi into your calculator, and then you can convert to a decimal. Make sense?
Yes, ma'am.
Cool. So give me that decimal now you were getting.
78,
Mm-hmm.
54.
Mm-hmm. What are my units?
The rest of the units.
Yeah, so remember units, we always have to put in units, not my decimals. What's my measurement units?
Oh, sorry. Centimeters.
Centimeters what?
Squared.
Squared. Super, super important, guys. Don't forget your square. Thank you very much, Jamie, for stepping up and
Raise your
answering
hand.
that one. Cool. So that's that. Into our brain break we go. Boys, please check yourselves. Let us represent correctly. I mean, I'm not a boy, but come on, guys. um,
No, ma'am, I'm just getting ready to answer the next question, ma'am.
there we go. Some boy representation. Uma, I was asking the boys earlier to answer, and nobody wanted to answer. So you're the first boy today to answer a question.
W me, I
I
think.
agree.
W me.
You can pick which one you want to do, Uma.
Which one is harder? So I want to do the harder one or the easier one? I'll see. I'll do the harder one. Yeah.
Okay.
So first of all, we don't have the height to calculate the area of the triangle, the whole triangle itself.
Mm-hmm.
So we need the height. So we have to use theorem of Pythagoras.
Correct.
So we can just say h squared for the height. Height squared is equals to no. Wait, 15 squared is equals to 9 squared plus height squared. Yeah.
9 squared plus. Correct.
15 squared is I think 125.
Not 100, but 200.
That's close enough, ma'am.
225, and then
Is equals to 81 plus h squared.
Mhm.
And now you have to transpose yes. And then I get 144 and 9 square roots, and h squared is equals to 12.
Okay. 144 is equals to h squared. Then we want to get rid of my square, so we're square rooting. My square and my square root cancel. So I'm left with just h on the side, and square root of 144 is 12. Beautiful, Uma. So is that it? Are we now done finding the height?
No, we are not.
Mhm.
So height is half of the base, and then you times it by the height. Yes. Oh wait, I never write the reason. Theorem of Pythagoras. But
There we go.
I told you in the start I'm gonna use theorem of Pythagoras.
You did, right? But you
I
have
did
to
tell you in the start,
specifically
ma'am.
say.
I did say, ma'am. Yeah. So first, you want to add up the bases for you to get one. No. Do they want us to calculate the dark one or?
So they want you to calculate the area of this triangle.
Okay, so I'm gonna say area is equals to half base times height.
So that's correct. The area of this triangle is equals to half of my base times my height.
Now area is equals to half of 11 times what's our height? 12. Yes.
Mhm.
Now half of 11 is 5,5
Mhm.
times 12. Now 5,5 times 12 gives me 66. So the area of the triangle is 66.
66 what?
Centimeters squared.
There you go.
Yes.
Centimeters squared.
Ma'am, I
Beautiful.
remembered, ma'am.
You were almost gonna forget. I could hear the hesitation, Uma.
Yeah, but we don't talk about the hesitation part. You see,
Correct. As long as you
stays
did it, you're
between
fine.
stays between the class. No one talks about it.
Okay, Uma, fair enough. Fair enough. Thank you for answering. That was beautiful. Before I actually take your hand, Itandili, well, Itandili, do you have a question or did you want to answer?
I want to answer, ma'am.
Okay, cool. Before I let you answer, can we all let me know, were we following what just happened or are we completely lost? Are we like, ma'am, I have no idea what just happened here. Lots of thumbs ups. I hope that you guys are being honest. because it's never gonna help you. Okay, Shady, let me know where I can help you. Where did you get lost?
Ma'am, when we were calculating the height, I thought we were
Mm-hmm.
going to use the 9 centimeter base with the 15 centimeter side to calculate the area.
That is what we did. No. Okay, so remember we didn't want to calculate the area of this triangle over here. Do you see that?
Yes, ma'am.
In fact, immediately what I want you to do is I want you to forget about this because can you see these are dotted lines, what I'm erasing? I've just erased dotted lines, right?
Yes, ma'am.
Meaning it was not part of my shape. Here is my triangle that they've given me, and they've given me the lengths of all of my sides, and they've now told me calculate the area of this triangle. So, Shady, do you agree when we're calculating the area of a triangle, we would have gone area is equals to half of my base times my height?
Yes, ma'am.
And do you agree that my base is 11?
Yes, but wouldn't. Okay, no, never mind. Yes, ma'am.
Okay. So my base is 11, but what is my height? Which one of these other two would you have used as your height?
Neither of them.
Neither of them, right? Because we don't want a slanted height. We want a perpendicular height. You with me there?
Yes, ma'am.
So what they then did is they drew these dotted lines. They extended out the base, and they were just trying to confuse you by really giving you these other ones. You didn't need them. What you did need was just this one and this to calculate this triangle here. So as you see, when we extend the base and we draw the height, it creates sort of another triangle over here. Do you see this green triangle?
Yes, ma'am.
So what we did is we know we are trying to calculate the perpendicular height. Do you see that?
Yes.
Which means that this triangle is a right angle triangle. You with me there?
Yes, ma'am.
Because it's a right angle triangle, I can use Pythagoras to calculate a missing length. You with me there?
Yes, ma'am.
And so we know the formula for Pythagoras is a squared is equals to b squared plus c squared. And remember, a squared is always going to be our hypotenuse, correct?
Yes, ma'am.
Now, in this triangle, which one is the hypotenuse?
The height. Oh, 15 centimeters.
Right. So 15 centimeters is my hypotenuse. Remember, it's opposite my right angle.
Yes, ma'am.
So we substituted in 15 over there. And then remember, it doesn't matter how you substitute the next ones in. We could have said h squared plus 9 squared. It wouldn't have made a difference. You with me there?
Yes, ma'am.
Then we solved this Pythagoras problem and we got that the height was 12. You with me there?
Yes, ma'am.
And then we substituted in that 12 of my height here.
Got it. Thank you, ma'am.
Pleasure. I hope if anybody else was lost, it all makes sense now. If not, let me know and I will definitely go through it again. Itandile, you're going to take the next one, and Uma, you can do the last one if there are no other hands. So Itandile, we have this shape over here. Which shape is it?
It's a rectangle, ma'am.
Why is it a rectangle?
Because of the 90 degrees and the opposite sides.
90 degrees and opposite sides. Cool. So now that we've looked at the properties of the shape, it's safe for us to now go and say, okay, this is a right angle. This is a rectangle. Now, what is the formula for area of a rectangle?
The area of a rectangle is length times breadth, ma'am.
Length times breadth, yes.
And then, ma'am, we substitute length with 9,25 and we substitute breadth with 9.
What?
With 4, ma'am. Sorry. We substitute breadth with 4 and length with 9,25 centimeters, which area of a rectangle is equals to 37 centimeters squared.
Beautiful. Thank you very much, Itandile. Cool. And then let us look. We have these last two up here. Uma, you can, and let me actually first check are the other hands. Nope. Uma, you can pick which one you want to do here, and I'll do the last one.
Okay, I'm gonna do the semicircle because it's harder than the normal one.
Okay.
So we know the area of a normal circle is pi radius squared.
Pi radius squared, correct?
Right. Area is equals to 6 comma 4. I mean pi times 6 comma 4 squared.
Pi times 6,4 squared, yes.
Now I am going to calculate 3,14 times 6,4 in my head.
Mm-hmm.
I'm going to take some time. I got the answer.
Mm-hmm.
The answer is 128,68.
Yes.
Is it okay if I just typed pi instead of 3,14? Will I get the same answer?
Yep.
Yes. Now I want to divide their answer by 2.
Mm-hmm. So when we do this, it's always, you must always tell us what you're calculating. So here we wanted to say area of 4, and let me make some space. So if you're going to do it in 2 calculations, you must always say what your calculations are. So here you're going to say area of your full circle is pi r squared, blah, blah, blah. Then we can do a new calculation and say area of the semicircle is equals to, what are we doing?
So we have to divide by 2, and when you divide 128,68 by 2, I am going to get 64,34 centimeters squared. Yes, I know I must say out, man.
Thank you.
And I do the full circle also, man.
You've done the full circle, yes. I added the units.
No, man, the top one, C.
Okay, give me a second though. I just want to show you guys another way. Now, if you didn't want to do 2 calculations, you could have combined this into one, and that would have looked like this. So from the very beginning, you would have said that the area of your semicircle is equals to pi r squared divided by 2. And you would have done this from the beginning, and you would have said pi times 6,4 squared divided by 2. You would have put that whole thing into your calculator, and you would have come to 64,34 centimeters squared. Okay. Uma, does that make sense?
Yes, ma'am.
Cool. Everybody else, are we with me?
Yes, ma'am.
Cool. Thank you, Liaho. Great.
Yeah, for the next one, I'm gonna hurry because I can see Itangile wants to answer. So I'm gonna say area of circle is equals to pi r squared, and then I'm gonna substitute and say pi times 24 squared, and I am going to get.
What length have they given us?
Wait, divide by 2.
So we're going to say our diameter is equals to twice our radius. They've given me my diameter. That equals twice my radius. Divide by 2, divide by 2. 12 is equals to the radius. With me there?
Ma'am, can I finish off?
Itandile, you can. Uma, I'm sorry, I'm going to sideline you.
Yeah, man, it's fine.
Thank you, ma'am.
Yeah,
Thank you for
yeah, it's
taking
okay
it.
because splitting the question makes it clear, man.
I think that's fair. Thanks, Uma. You really represented your boys today. Itandila, let's finish off for the girls. What are we doing now?
Ma'am. Ma'am, we're gonna say A is equals to pi r squared.
Mm-hmm.
So, ma'am, since we found out our radius is equals to 12, so you're gonna say pi is 12. Ugh. Pi. To the power of 2. Then,
You
ma'am,
go.
our radius, ma'am, is gonna be pi to pi and 24 because our radius is 12. So 12 times 12 is
There
wait,
you go.
it's 144, ma'am. Sorry,
There you go. What is pi
144.
times 144? What's the easy way to write this?
It's 400. It's 452,38.
Okay. When I talk about the easy way, you guys, I just always mean this. Just write it as if you're going to act as if pi is x. If I told you what's the easy way to write x times 144, it was going to be 144x, right? So that's the same thing with pi. Now, Itandile, give me that decimal you're getting.
Ma'am, my decimal is 452,38. Then when it's in, ma'am,
round off nicely for me.
it's gonna be 452,8. Then when I
So remember, we're rounding to two decimals.
Oh yes, ma'am. So it's gonna be 452,4.
Two decimals. So Itandile, if my decimal looks like this, 452,389. If I want two decimals, it means I want these two to stay, right?
Yes, ma'am. So sorry. It's gonna be 452,9.
There you go. 439
centimeters squared.
Beautiful. And that brings us right to the end of our lesson. And actually, Itandile, it's millimeters.
Oh wow, ma'am. Oh wow.
I actually saw that. Thanks to Bree. Thank you, Bree, for that correction. Okay, guys, that's it for today. If you have questions, please stay behind and ask. If not, we had a pretty good lesson today, guys. Thank you for that. Go have supper, enjoy the rest of your evening, and I will see you guys on Thursday again.
Bye, ma'am.
Bye.
And the podium. Oh, you already showed us. Never mind.
I did. Bye, Nikita. Okay. Uma, you said you have a question?
Yes, ma'am. Can you go on a blank page? This was my maths division because it's confusing. So can you draw a triangle? And then you want an extended line.
Draw a what?
Draw a triangle.
Okay. Draw a triangle. Yeah.
Now there's one line going up next to the triangle.
Like up here. You know what they say? It is what it is.
Ma'am,
What's wrong?
It's going like a slanted shape, like slanted towards the right.
So like that.
Yes, and at the bottom there's a straight line, like.
So this is extended.
And then the angle, it's labeled. This corner, the extreme left corner of the thing is labeled P.
P.
The part where the vertex over there is on the straight line. That's R, and on the extreme right at the end on that line, that's T. The top of the triangle is Q. And the top over there is S. The angle underneath Q is Y. Z is by P. And X is in that straight line by RT, like it's and there's one angle in the by QRP that's 60, like QRP, So how do you calculate the diagram? Because I was stuck on this, like I was spending whole day on this question for the revision.
Okay. Did they give you any other information? For example, did they tell you there were parallel lines?
Yes, ma'am, they did.
So these were parallel lines?
Yes.
Okay, so immediately I'm gonna try Immediately I'm seeing an N over here. So I know then that this angle is going to be equal to this angle. So all I know for now is that that's also Y, but that doesn't really help me as yet. What else do I see? There's an F over here. So this is an F. Do you see that? So that means this is equals to this. So I'm thinking maybe you have given me something slightly wrong in the diagram, because from that I'm getting that Z should be equal to X. Are you seeing that?
Yeah, I spoke to my math teacher. He said nothing about it. He said I must just solve it. I must find a way to solve it.
But you're sure this is the correct diagram?
Yes, ma'am. I have the revision thing, the revision sheet right next to me, ma'am.
Okay. So then that means if we're gonna go with that, that's fine. Oh, I didn't want to do that. I just want to get rid of that. Thank you. So immediately I'm going to make a note that this can also be X and this can also be Z, because X and Z are equal to each other. You with me there?
Yes, ma'am.
What else? I'm seeing an exterior angle of a triangle. So this is my
Yeah, but the
triangle.
problem with the exterior angle, you don't have another angle to calculate the exterior.
I see what you're saying, but I just wanna let's draw it out. So it's going to be my exterior angle is going to be, and I'm gonna use Z. I'm gonna say my exterior angle is Z plus Y, and that is going to be equals to Z plus Y. Okay. I see what you're saying there. What else are we getting? I see a U. So this over here is a U. Oh, please. There we go. This over here is a U, which means X. So we also have that if we take Z plus 60 degrees plus Y, that is going to be equals to 180 degrees. So, Uma, have you learned how to do simultaneous equations?
No, ma'am.
Okay, so let's try to figure out a way to do it without that. Hmm. So if you n, so this is the only, if that's the only n, and that is the only u. Then exterior angles.
Bye, ma'am.
Bye, Liacho. I'm
Bye.
surprised there are still people in here.
Right. Also, ma'am, can I answer my question quickly, ma'am? So, ma'am, for next week, ma'am, yes, ma'am, next week, the boot camp is still going to be the same times as this week.
Yes. So, what were the times? Let's just check again. It was, Umar, your question is honestly stumping me as well. We have some angles in a triangle. We have that Z plus 60 plus Y is going to give us 180, but that's the exact same equation that we got up there. Uma, are you still here?
Yes, ma'am.
Okay, great. And you're sure you don't know how to do simultaneous equations?
Yeah, ma'am, we never learned that thing this year. I think we're going to learn it next year.
No. Okay. Back. What else? Uma, you're definitely like, I don't believe that this is all the info. Are you sure there is no other information that you're missing?
I'm sure, ma'am.
Did they tell us that these are equal?
No.
Okay. What else could help us? I don't actually know. So I think I said that these were angles on a straight line.
Ma'am, we can use angles on a straight line because, like, ma'am, if you could see, if we do angles on a straight line, ma'am, it will make that without the long side of s. If we remove s, that means that we could do angles on a straight line and it could be equal to 120 degrees. Then when you half 120 degrees, it will be equal to 60 both sides. For y and x.
So you want to leave out this part?
Yes, ma'am. That's what I'm thinking. To leave out that part, and then we use angles on a straight line, which is going to be 120 degrees. Then when we bring back,
so are we leaving out the 60 or are we leaving out this?
We're leaving out x, ma'am.
Okay, so we're leaving out x, but then that's not angles on a straight line. Remember, when we use angles on a straight line, remember your angles must make a full semicircle. This is not a full semicircle.
Yes, ma'am.
You're seeing where that's not going to...
Ma'am, can't you say it's an equilateral triangle because one angle is 60, you can say the others are 60? No.
We can't, because just because the one is 60, we can't assume, because this could be 110 and this could be 10, you know.
So, because you have to prove that it is.
That's why I'm saying there's something that is missing over here. If I was going to say that it was an equilateral triangle, if I can prove that x is equals to 60, because if x is equals to 60, then that means z is equals to 60, and then that means y will be equal to 60. But we don't have enough info to do that.
Oh, ma'am, I messaged my math teacher. He says add 20 degrees between the 60 and x.
There we go.
Yeah.
See, so this makes it a lot more doable. Do you see now we can use angles on a straight line?
So that's going to be x is 100, z is also 100, and we're going to make y 20.
Yeah, yes, 20. Yes.
Correct. There we go. See, that was solved. I was getting a bit worried, but I knew there was missing information, because if you didn't know how to do simultaneous equations, then there was no other way to do it.
Yeah, I only messaged him now because it was getting like confusing.
Good thing that you did message him.